guys, Miss Velasco again, and we're dealing with more equivalent expressions. I think you'll find this lesson to be a bit of a review, and I think that it will reinforce what we did yesterday, so it should make tonight's homework really easy, and it won't be a very long video tonight. I want to take you back to when I was teaching you mental math, and you had to multiply a large number by a smaller number. And I had you break down that larger number to have it make sense so you could do it quickly in your head. I'm going to give you an example. Let's say 9 times 34. Now remember, I want you to be sophisticated mathematicians, so I'm going to get rid of the x and I'm going to use the dot. Pretty soon I'll just get rid of the dot altogether and just use parentheses, right? But for right now, 9 times 34. I told you to think of it as 9 times 30 plus 9 times 4. And this was easy because you know that 9 times 3 is 27, and then you just stick on that 0 at the end, right? And you're going to add it to 36, which is 9 times 4. And so you end up with, add those two together, you end up with 306. That's so that you can do it in your head. Well, kind of keep this in mind as we're looking at our problems tonight, okay? Just a little review for you. So give me a second. I'm going to just do one long video, so you're going to have to see me erasing and see the back of my head. Sorry. It'll just make posting it a lot easier. So this is a distributive property, what I showed you. And it's breaking apart bigger numbers. So the reverse is important too. I'm sorry, I'm reading my notes because I sat down and tried to make notes to make it go faster. So the reverse is important to know too, and you're going to see that in just a little bit. Okay, back to the title, equivalent expressions. And what does equivalent mean? It means that they're the same. When you plug in values for x or for the variable, you're going to get the same answer in both expressions. So that's what equivalent means, that they're equal. And the way you check that again is by plugging in some numbers for your variable. It's really good if you were to plug in, let's say, work it and plug in 2 for the variable, and then work it again and say plug in 5. So if you check it with 2 different numbers, then you're really sure your problems are correct. Let me give you an example of the distributive property and what I'm talking about, and it should be making that whole concept a lot more solid in your head because we've been doing this now for a couple of days. So let's take 5 times, I'm going to leave the dot out. We're going to be sophisticated today. 5 times 3x plus 2. Okay, and now you need to use the distributive property. So you can make the arrows above or below. Tonight I'm going to make them below because I didn't leave enough room up above. That's the only reason. There's no rhyme or reason to it. 5 times 3x. What is 5 times 3? 15. Put the x in there. Now distribute the 5 out to the 2. And what is 5 times 2? It's 10. What is the operation? It's addition. So these two expressions are the same. If you were to plug in, say, when x is equal to 2, what would it look like? Right here, it would be 15 times 2 plus 10. What is 15 times 2? 30. Plus 10 equals to 40. Let's look at this. Let's look at this one. 5 times 3x plus 2. And again, when x is 2. 5 times 3x, that's 15x. 5 times 2 is 10. 15 times 2, 30. And you got your plus 10, the same thing. But I could work that a slightly different way also. I could say, okay, before I even do that, I'm going to substitute in the 2. 5 times 3 times 2 plus 2. Well, what is 3 times 2? It's 6. Now you've got 5 times 6 plus 2. And I actually don't need this one, sorry. Okay? So you've got 5 times 6 plus 2. Well, what is 5 times 6? It's 30. What is 5 times 2? It's 10. What is that? 40. You could also do it this way. 5 times, what is 6 plus 2? 8. What is 5 times 8? 40. I've shown you a couple different ways, but we've arrived at the same answer. If I was to substitute in a different value for x, I would get the same result. Both expressions would be equivalent. They would give us the same value when all is said and done. I'm going to give you another example. This time I'm going to try and draw it for you. 3y plus 2 minus y. And you'll see some problems like this in tonight's homework. So remember we talked today about the commutative property? Well, the commutative property lets you gather like terms. So if you look at this, we've got a y and some y's, and then we've got this 2. I'm going to draw this out and show you. Here's 3 y's, 1 y, 2 y's, 3 y's, right? Plus 1, 2, minus a y. So I have drawn out this expression. If I gather my like terms together, I've got 3y minus 1y. So what does that leave me with? 2y plus 2. Let me write it another way. 2y plus 2. Now, let's see if we can solve that problem and see if we come up with the same expression. Bring your like terms together. You could even do it this way, boys and girls. 3y minus y. What does that give you? Remember, the coefficient is 1 when it's not shown. So that gives you 2y plus 2. Do you see how I just showed you that I showed it to you in pictures and we came up with the same expression as this one? Okay, the same value, the same exact expression. I just wanted to illustrate it for you or draw you some pictures. All right, let me go on. And some of the problems draw pictures, so that's why I took the time to do that. You need to see it in pictures as well. All right, let me give you a couple of more problems. We're almost done, believe it or not. 3 times y minus 8. Oops, that's a parenthesis. Sorry. It's not a very nice parenthesis, is it? There we go. 3 times y minus 8. So we have to distribute that 3. What is 3 times y? It's 3y. What is 3 times 8? It's 24. What's the operation? It's subtraction. So these two expressions are the same. How do you know? Let's plug in something for y. Let's say when y equals 2. So over here we're going to have 3 times 2 minus 8. Oh, I don't like these numbers, but that's okay. We're going to do it. 3 times 2 is 6. 3 times 8 is 24. And that's our, excuse me, that's our expression. Let's put it in over here and see what we get. 3 times 2 minus 24. What is 3 times 2? 6 minus 24. Are they the same? Yes, they are. I don't like that because 6 minus 24 is going to take us into negative numbers, and I really have only begun to show you negative numbers, but you can see that the two expressions were the same. Let me show it to you. 3y minus 24 and put in a different value. 3y minus 24, this time when y is equal to, I don't know, let's say 10, okay? So now we're going to have 3 times 10 minus 24. Now we get 30 minus 24, and so our answer actually is 6. Let's try it a different way. When this other expression, when it's 3 times the quantity of y minus 8. And again, we're plugging in 10. Can you see that? Yes. So it's 3 times 10 minus 8. 3 times 10 is 30, because you have to distribute it there, but you also have to distribute it there. Minus 24, the answer is 6. These two expressions totally check. We've checked them with a 2, we've checked them with a 10. They are equivalent. They will give you the same value. Okay? Let's move on. Almost finished tonight. Let's look at a different one. 8x plus 18. 8x plus 18. Now, what we were going to do is we're going to pull out a common factor. Remember that from yesterday? Common factor. Well, let's see. What makes 8? 2 times 4. What makes 18? 2 times 9. Oh, let's use our 2's. Okay, that would be our thinking. We would do that in our head. So let's pull out a 2. And 2 times 4x plus 9. Do you see where I got these numbers? 2 times 4 was 8. So here's the 2 and here's the 4. And 2 times 9 is 18. Here's the 2 and there's the 9. I hope that makes sense, because this one was the one that tripped up some of you today on the quick check. But this is pulling out a common factor. You are much more comfortable distributing this, and you'll get that. That would be 8x, and then distribute it over here, plus 18. It's the same problem. It's just here I use the distributive property, and here I use the reverse of the distributive property, pulling the common factor out of that 8x plus 18. But you know what? This homework tonight was a little tricky. And I think you might find the quick check tomorrow a little tricky as well. They got sneaky. They threw in all different kinds of things. For instance, what about this? Is this the same thing? 3x plus 3x plus 2x plus 9 plus 9. Is that expression the same as that one? I'm going to let you think for just a second. 3x plus 3x plus 2x plus 9 plus 9. I hope you say yes, and I hope you see that 9 plus 9 is 18. And 3x and 3x and 2x is 8x. There's 3, 6, 7, 8. 8x plus 18. Same thing. They just broke it down even further. They're being tricky. Now, instead of doing it this way, watch. What if I did it this way? 3x plus 9 plus 3x plus 2x plus 9. Is that expression the same as that? I hope you say yes, because look, use the commutative property and gather your like terms. So you're going to look at 3x and 3x, which is 6x, plus 2x, which is 8x. And then you've got your 9 plus 9, which is 18. They're a little tricky in the homework tonight, so I hope that makes sense going over that with you. And believe it or not, that's it. So have a great evening. I'm a few minutes late getting this up to my YouTube channel, and I'm sorry for that. But you guys said you stayed up late. So finish up your homework and go to bed. And I'll see you in the morning, okay?